In this video, we continue to take a look at tidyverse and packages in the tidyverse space. DPLYR. DPLYR is a package in tidyverse that is used for the transformation of data and the performance of a variety of statistical and mathematical operations on data. One of the important reasons that a package like DPLYR exists within the tidyverse space is that it allows for transformations. Transformations are important so that the data can be structured in a way that's suitable for analysis. These transformations could be summarization operations, filtering operations, aggregation operations, so on and so forth. One of the other important operations that DPLYR supports is workflow operations. And it supports workflow operations with something known as the pipe operator. The pipe operator is a combination of three symbols: the percentage sign, a greater than sign, and followed by another percentage sign. These three symbols together form the pipe operator. The purpose of a pipe operator is such that we can take data from one step to another without specifically having another line. We can use the pipe operator to take the output of one operation and pipe it or pass it to the input of another operation or function. The pipe operator can be used across all packages in the tidyverse space. In the example below, you might think of white data as holding data for a data frame, and the results of white data, the data set, is piped to the gather operation that is performed through the use of the tidyr package. The result of then the gather operation is stored in long data. Let us take a look at some of the transformations that DPLYR allows. One of the operations that DPLYR allows us to do is to select columns using the select function. In the examples you see in front of you, we are selecting variables in a variety of different ways. The first line indicates that from the long data frame, we are selecting two specific columns. The second example indicates that we are selecting the columns based on column positions. And the third example suggests that we are using the function starts with to select columns that start with the letter C. Selecting variables, as you can see, takes place through the use of the select function. And inside the select function, you can select the columns in specific ways. In addition to selecting columns, DPLYR also allows us to filter rows or to select rows. The way it does that is through the use of the filter function. We can filter rows on a variety of different criteria in a variety of different ways. In the first example, you see again we have long data, a data frame that is piped into the select function. That means we are picking our columns, and in this case we are picking three columns: year, country, and CO2 per capita. That is then subsequently piped into the filter function, where we are only selecting those rows where the year value is greater than 1980. In fact, when filtering, we can specify multiple conditions. And you can see in the second example that in addition to filtering on year greater than 1980, we are also selecting only those rows where the country value is Canada or the country value is USA. In this case, you can see the AND operator, allowing us to concatenate multiple conditions as part of the filter operation. In addition to filtering rows based on row values or values in specific cells, we can also select rows based on positions. You can see in the third example, long data has been piped to the select function, selecting specific columns, and subsequently piped to the slice function. The slice function allows us to indicate the set of rows that we are interested in based on the positions of those rows or the row indexes. One can also filter rows based on orderings of values. In this case, we are using the top_n function. The top_n function gives us the top 10 values of CO2 per capita in the data frame long data. These are only some of the ways in which DPLYR allows us to transform our data set by filtering on row values. There are a variety of ways to create new columns, and DPLYR uses the mutate function to actually create new columns and change existing columns. In the first example, we see long data is piped to the mutate function. Now, the data in the long data frame is piped to the mutate function. And what the mutate function is doing is taking CO2 per capita and creating a new column, CO2 per, which is set to CO2 per capita divided by 2. And CO2 per is equal to CO2 per capita raised to 2. This is just a generic example of how to use the mutate function in case we had the actual actual population. We might actually decide to calculate the CO2 value for the entire country by multiplying it by the population, and so we don't have it necessarily per capita. The second example of the mutate function indicates how we can create another column, in this case high-low. Long data is piped to the mutate function, and the mutate function is creating a column called high-low. And the high-low column is getting values high or low based on the evaluation of a condition. The condition is if else. We are evaluating whether CO2 per capita of a specific row is greater than 20. If it is considered high, else it is considered low. And so the high-low column in the new data frame is going to have values of high or low based on whether CO2 capita corresponding in that row is greater or less than 20. In the third example of the mutate function, we see that high-low is still being generated and stored in the high-low column. However, in the case of the third example, we see if else CO2 per capita is not compared to the absolute value of 20, but the mean value of CO2 per capita that is present in that column. The mutate function allows us to also recode values in existing columns. In the last example, we see that the mutate function is manipulating the country column, and it is recoding the country column where the value is United States to be changed to be USA. DPLYR also allows us to arrange the data. Arrange data implies the sorting of data. And so it is accomplished through the use of the arrange function. And in the two examples, we see that we can either arrange in descending or ascending order. We have to specify to the arrange function what the order is. The default order for sorting or arranging is ascending, And if one wants to specify a descending order, one has to use the DESC function prior to the name of the column one wants sorted. One of the more powerful features of DPLYR is aggregation or summarization. It does this through the use of group by and summarize clauses. The purpose of the group by clause in DPLYR is to select a specific column along which we wish to aggregate our data or wish to summarize our data. In the example, long data is piped to the group by function that allows us to indicate that we would like to aggregate or summarize our data frame or data set by the country column. The summarization we want is we wish to summarize and create a new column X that holds mean values of CO2 per capita for each country for the entire data set. We also wish to create, as part of the summarize function, a count column that holds the number of rows that were associated with this calculation, which is provided by n open close parentheses. Summarizations and aggregations tend to be one of the most powerful features of DPLYR.